12 again on the same topic, grade 12 physical sciences, paper 2, with the focus on electrochemical cells. Earlier on I was here, we were discussing the galvanic cells to say there are pretty much so many things involved in a galvanic cell, and then we said we're going to also touch base on electrolytic cells as well, because I really need you to also get that concept. That is your question 80 in the exam papers, your national papers for grade 12. So we will continue from where we left so that we can cover some few questions around this topic, and we also be able to explain the information in and around that topic. So as we commence again, all right, we'll be moving to questions. I hope you have your periodic table ready next to you. I need you to have your periodic table ready. I need you to have your exam guideline ready. I need you to also have your standard reduction potential table next to you, because of those are the documents that you and I will be using so that we can be able to answer the questions here. So what we have done is we've collected the questions from the previous question papers, the repeatable questions that they normally ask, and also we are going to teach you how to respond to those questions and what is expected from a learner and what does the marker also focuses on. So I've provided you with the periodic table. As you can see in your slides, I've provided you with the periodic table. I will be making use of it, and then this is pre-knowledge. We believe that you have done your grade 11, so you know how the oxidation numbers work, you know how the meaning of oxidation and all those things. And I did explain most of the content in my first episode, so you are in line with whatever that is expected from you as a grade 12 learner. So we'll dive through. I'm just going to emphasize on very few things, right? Just as a walkover to what we have dealt with. These are the rules of oxidation numbers. You know them from grade 11. And then you will be asked to define what is a galvanic cell, define oxidation number, define oxidation in generally, and reduction in terms of oxidation and electron transfer. So those are some of the definitions that you can expect in this question. And then sometimes they normally say, also define the agents that are involved. Remember we said there's an oxidizing agent and a reducing agent in these reactions. So you'll be asked to define that. And then you'll be asked to define anode, you'll be asked to define a cathode, and you'll be asked to define what is an electrolyte. If you're asked to define oxidation in terms of electron transfer, we are saying oxidation is the loss of electrons. Reduction is the gain of electrons. Please pay attention to this definition. They are going to ask you. So remember we said the easier way to remember this is when you follow the oil rig and the Leo and the gear abbreviations. They help a lot. Right, oxidation is an increase in the oxidation number. So grade 12, if they ask you to define oxidation according to oxidation numbers, we say it is an increase in the oxidation number. 2 marks in your exam. Then if we ask you to define a reduction according to oxidation number, that is a decrease in the oxidation number. Very simple and straightforward. If we ask you to define oxidizing agent, it is a substance that gains electrons, or it is a substance that is reduced, grade 12. So it is very, very important for you to define it this way. It is a substance that is being reduced. What is the meaning of reduced? It means oxidation number decreases. So I need you to understand that. So what is, if they ask you to define what is a reducing agent, it is a substance that loses electrons. So what is meant by losing electron? We're saying the oxidation number increases. So a reducing agent is mainly a substance that is oxidized. So it is very important in grade 12 to get this definition. 2 marks in your pocket. An electrode, it is a solid electric conductor that carries the electric current to a non-metallic part of the circuit. Then please pay attention on your anode and your cathode. So those are some of the abbreviations that we use. Your red cat, I spoke about this earlier on. So in the anode side, that's where we have our reducing agent or oxidation take place, or a substance being oxidized. So a cathode is oxidizing agent, reduction takes place, and the substance is being reduced. So these are just a quick reminder to what is going on. So I'm looking at the question. Can we go through this question together? Question 8. Right. Let's start here. Let's start here. If you're asked to write down the oxidation and the reduction reactions from this half fraction that is provided above there, I need you to do that. Identify the anode and the cathode. I need you to be able to do that. Remember, I spoke about the ANC rule. So you can see that from this half reaction that is given there, I can identify my anode, I can identify my cathode. So this is what I'll be expecting you to do. Write down the balance overall reaction. This is what I'll be expecting you to do. Identify the reducing and the oxidizing agent. We're always going to ask you that question. And also write the cell notation. So I want us to go through these questions step by step. Then we can solve all of them. Let's start here. This is taken from the national paper. It is taken as question 3, but we are going to take it as question 8 in the examination. So the question is, the diagram below represents a galvanic or a voltaic cell functioning under standard condition using silver and an unknown metal M as electrodes. The initial reading on the voltmeter was found to be 0.93 volts. So I want you to study your galvanic cell. There are 2 half cells. There's silver on the first electrode. There's a beaker with an unknown metal. That's why they are calling it metal M. So the first question that they are asking is, which electrode is cathode? How do you know that it's a cathode? How do you know that it's a cathode? So I told you that there is a positive and negative. Now, I also want you to notice something there close to your voltmeter. I'm just going to go there with my cursor. Just check there. There is a direction of how the current is flowing. So as you can see, the electron flow is coming from the M moving to the silver. So whenever we are asking you a question to say which electrode, you follow the electron transfer. So the solution is, it is silver. That's where the cathode takes place. Next question, 3.22. Identify electrode M by performing relevant calculation. So here, grade 12, we make use of what is called the standard reduction potential table, how to calculate the electron. So we need to find M. So what do? You go to your formula. E theta cell is equals to reduction minus oxidation. So we are going to take the energy that we get from the EMF. We were told that the EMF, the voltmeter was registering 0.93. So that is the theta cell. Then we are going to substitute the reduction. Remember, we said the reduction is where cathode take place. So you go to your standard reduction potential table, you go and check silver. Silver was found to be 0.80 and then minus oxidation. Why are we saying minus oxidation? Because we know that on electrode M, that's where oxidation is taking place, but we don't know what is M. So you make oxidation the subject of the formula. So the answer is 0.13 volts. So as soon as you got an answer which is 0.13 volts, you need to take this answer back to the standard reduction potential table. So when we're checking there, we discover that the electrode which has an EMF of 0.13 is lead. So this tells us that in that electrode M, the one we're saying it was unknown, it's actually lead. So lead is reacting with silver in this reaction. So this is what we were looking at. Alternatively, another solution could have been you use half cell. So you take silver half cell, and then we are getting the electrode as 0.80. That we can get it from the standard reduction potential table. But remember, there were 2 electrons that we were using from the silver. So we are going to use M. even though we don't know, but we're going to say M substance plus 2 electrons, which give us M. We know that oxidation is taking place there, but the total energy that we had was 0.93 volts. So if you work around there, the mathematics behind there to say 0.93 and 0.80 and 0.13, the solution is 0.13 volts. So from 0.93, we subtract 0.80, we get 0.13. So that's another option of how you can do this. So this is your basic mathematics here. So you were just finding the difference between the two. And there is a mark for identifying. I want you to notice something, grade 12. You know, with these standard reduction potential table, there are some EMF values that are given in terms of positive as well as in terms of negative. So it is important for you to plug it as it is, substitute, and get the answer. Let's move back to the next questions. We are given question number 3.3. They are saying to us, if the salt bridge is now filled with a sugar solution. Remember, when I was explaining content, I said to you, in the salt bridge, we normally put salts. Example, sodium chloride. I said we can also use potassium chloride. We can also make use of potassium nitrate. But the examiner here is saying, let's change the question and tell you guys that what if on the same salt bridge, we substitute it with sugar solution? What will the voltmeter read? So, we know that sugar is a non-conductor of electricity. There's no way that the electrons can pass through sugar. So when we're asking you a question like what, that means you're not performing calculation, your answer should be a one-word answer. What will the voltmeter reading be? The voltmeter reading will be 0. I think we can all agree. Why 0? Because there's no way that sugar can transmit or electricity or allow the movement of ions. So that won't happen in this case. So that's why it was a 1-mark question. We needed you just to respond with 0. Let's check another question. I'm still giving you galvanic and I want you to look into it. So this galvanic cell, which electrode is the cathode? I want you to study that diagram very well, grade 12. I'm looking at copper, I'm looking at platinum. In my salt bridge, there's potassium chloride. As you can see, it's KCl. Then there's an oxygen that is being put in there. Then there's a voltmeter. And in my solution, I do have a peroxide together with copper there. So these are easy questions, grade 12. I need you to answer them as quick as possible. So let's start. Which electrode is the cathode? You study the diagram. I'm looking at copper, I'm looking at platinum. Where is cathode? Just to give you a tip, remember what did I say? Cathode is where reduction takes place. So now you need to check, is reduction taking place at the copper? Is the reduction taking place on the platinum? You have to check that. But what are we getting? We are getting that in this case, platinum, it is the cathode. So platinum, that's where cathode takes place. Next question, write down the oxidation half reaction. So if cathode is a reduction taking place on the platinum, rest assured that copper, that's where the half reaction of oxidation is taking place. So you go back to your standard reduction potential table, you write the one for peroxide. I'm looking at peroxide, which is O2H and with 2 electrons and H2O2. So grade 12, look at this. In your solution there of platinum, one of the things that was there was hydrogen peroxide. So oxidation is taking place there. So if we are asking you to write the oxidation half reaction, we can make use of that. Next question, write down the reduction half reaction. Reduction, I still see CuO2. We can get that from the from the standard reduction potential table to give us Cu2 plus and a half reaction. Now, I want you to notice something there with my solution in grade 12. As you can realize that we have swapped the solutions. The O2H was for the previous question, the one that says write down the oxidation half reaction, and then write down the one for reduction. It is the one which is CuO2 and Cu2 plus. Then next question, which you're always going to get, write down the balance net reaction. So you make use of your oxidation and your reduction. So let's go and check the solution. What is expected from a grade 12 learner is for you to say Cu, then / Cu2 plus with the salt bridge there, and then we have O2 with hydrogen gas together with the peroxide. Now, I want you to notice something. One of the things that we normally don't share in classroom with our educators is the fact that these electrons, they need to be metals. So having something like hydrogen peroxide there, that is a gas. So that's why if you check my solution at the end, I added the platinum, because of we are seeing this hydrogen peroxide is inert. So it cannot transmit electricity. That's why we add the platinum there to substitute. Right. Next question. Write down the cell notation. That was the cell notation that was expected there. And lastly is calculate the E theta cell, which is the EMF. So the formula is still the same. Reduction minus oxidation. So we are going to say 0.68 for the cathode minus 0.34 for the anode. The answer was 0.34, which is still indicating that is a spontaneous reaction. I want to believe also that your educators did explain to you that when you normally get an EMF that is a positive, it tells us that that is a spontaneous reaction. Very, very, very important. Let's look at another question. This is another version of how they can ask these questions. Now, if you check grade 12, it's 16 marks there. So you need to be able to score that 16 out of 16. Let me help you today so that you see how what is it you can do. Now, one of the learners asked me in the previous, lesson or in the previous classes to say, you know what, Mr. Moyo, sometimes they don't offer us the actual galvanic cell diagram. And this is it. Look at this question. They just tell you that we have one half cell, which is A. We have Cu2 plus, which gives us Cu. Then they go and say half cell number B, we have Ag plus, which gives us Ag. So what am I doing? I'm not offering you the actual diagram, but I'm offering you the information that you're going to see even if I give you the diagram. So let's answer the question. The table below shows the two half cells, A and B, that are used to assemble an electrochemical cell under standard condition. Now, 8.1. State the energy conversion that takes place in the cell. I've done this before. I've shared this with you when I was teaching content. What do we get? The energy conversion is always from chemical to electrical. So for you to say that, you get 1 mark. Next question. Calculate the mass of the silver nitrate used to prepare 150 cubic centimeter of the electrolytic solution on a half cell number B. So what is expected there from a grade 12 learner was for you to make use of the formulas. So this, we are integrating a little bit of some quantitative aspect, stoichiometric calculation. So I'm giving you the volume of the solution, and then what you know as well, you can have the molar mass of HENO3. So you go back to the formula of the stoichiometric calculation. They want you to calculate the mass. So we know that the concentration is always 1 mole per decimeter cubic. So you have your concentration, you have the volume. That means you can be able to calculate the number of moles. So if you can get the number of moles, then it means you can take it back to the formula that says N is equals to mass over molar mass. Then you can find your mass there. So that was 4 marks that was expected from a learner. So it was direct substitution and you can get the answer simple and straightforward. Number 8.3, the question is define the term reducing agent. I did tell you that you need your exam guideline in order to do this question. What is the reducing agent? Where do we find the reducing agent? I'm trying to give you ideas of how you can remember the definition. Reducing agent, where do we find the reducing agent? We find the reducing agent under oxidation. So, it is the substance that is being oxidized. That's what we defined it. So a reducing agent is an agent that is, or it is a substance that is being oxidized. So very, very, very important. So a quick way to help you remember this, we said we have oxidation and reduction. So if oxidation is a loss, reduction is a gain, then there are two agents that are involved there. The agent is called the reducing agent and the oxidizing agent. So in oxidation, we find a reducing agent. In reduction, we find an oxidizing agent. So that's a simple way of remembering it, grade 12. So this one is bookwork. It's also there in your exam guideline. So you define to say it is a substance that is being oxidized. So you get 2 marks for that. 8.4, name or a formula of the reducing agent. You go and check there. What is being reduced there? So I'm seeing half cell number A. There's something which was Cu2 plus, now it's just Cu. What happened? There was gaining of electron. But if you look at half cell number B, we had Ag plus and Ags to Ags. So what happened there? We are also observing that there was a little bit of oxidation that took place there. So name the reducing agent. Where do we find the reducing agent? I said we find the reducing agent in the oxidation. So in that case, which substance undergoing oxidation? It is a substance that decreased in what you call the oxidation number. So that is your Cu. Write down the balanced equation for the reaction. You always take that. So a balanced equation involves the two. So remember, we still follow you write oxidation, you write reduction. So in this case, it's going to be Cu plus Ag, and then on the equal sign, you're going to write your Cu and your Ag plus. Very, very, very important. 8.5, for you to get the 4 marks, I want you to go and calculate the EMF of a cell. Remember, you are already told on the question to say you have copper, you also have silver. So you go to your 4B table, you go and extract the EMF values there, and then you substitute. Especially when they say calculate the initial EMF, that means you simply substitute, you get the answer. So that's how you get the 4 marks. And last question, how will the EMF of a cell be affected if the concentration of copper ions is half? I'm taking you back to the standard conditions. We said one of the standard conditions of a galvanic cell is the concentration should be 1 mole per decimeter cubic. Now, what happens if the concentration is halved? Will that increase the EMF? Will that decrease the EMF? Or the EMF will remain the same? I'm provoking your intellect levels here, grade 12. What is going to happen if the concentration is halved? So, remember, concentration should be 1. For us to get the EMF of the cell, we need to know the substances that are involved there. We need to have the concentration level at the standard concentration level. So in this case, what will happen? It's increase, decrease, or remain the same. You just have to choose one answer. So my solution to you will be, remember, the concentration should need to be 1. So in this case, if we have the concentration of copper, that means we are causing an impact on the reaction. We are not using sufficient concentration. As a result, the EMF will be affected as well. Right, so in this case, the EMF will be decreased as well. as your solution. So it is very, very, very important to realize that grade 12. So that's how you get your 16 out of 16 in the question paper. Let me see if I still have more questions to expose you. But that is generally what they normally ask in the examination. So your galvanic cell, they ranges from 12 marks, 14 marks, 18 marks. It depends on the examiner on that year. So the question that is on your screen is still a continuation of electrochemistry, but with the focus of electrolytic cells. So when we meet next time, I'll make sure that I do touch base on the electrolytic cells. There are 5, so I'm going to have to explain those electrolytic cells to you, and then we can come back on the applications of the questions. So grade 12s, overall, that's what happens on the galvanic cell. I hope you've learned a way of how to respond to these questions, and you are going to take that into your examination, and then you'll be able to get the mark allocation that we need. Remember, we need to study to get the results that we're looking for. We need to even do much more. It takes one to do a great work. So I'm advising you to go back. This is a topic that really needs you to be there, that needs you to study it, and needs you to understand it. So my advice to you is go back. I know it may be overwhelming to say I'm dealing with a lot of substances, I'm dealing with a lot of explaining that I need to do, but with constant practice, you will be ready for the examination. Grade 12, thank you so much. We will leave it here for today till we meet again.